Hi, it's Gary. Welcome to today's video. It's been a while since I last did a comic based video, so today, I thought I'd fix that. Today's video, could Iron Man fly? So from the comics and the movies, we all know that Tony Stark, he's a talented engineer and he built the Iron Man suit. We often see him flying around in it, don't we? But could he really do that? Yes, I know, the comic, the movies, they just make believe, but it does open up some interesting lines of research. To answer the question, we actually need to understand the forces that apply when something is flying. We'll start by looking at the most common man-made flying machines, aeroplanes. They're able to fly due to four main forces: thrust, weight, drag, and lift. These forces, they work together and at times opposite each other, but the result is the plane, it can fly. Thrust, that's the force that moves the plane forward. For an aeroplane, it's generated by the engines. For Iron Man, this comes from various jets that are built into his suit. Drag, this is easiest to see as being the opposite of the thrust. As the plane is moving forward, it's pushing through the air and pushing the air around it. This causes the drag force, which acts to slow down the forward movement of the plane. Weight, this is the force of gravity that's acting on the mass of the plane. Mass, that's how heavy something is. And weight, that's the force due to the gravitational field on that mass. Now, we often use the term weight instead of mass. If asked how much you weigh, you'd reply 70 kilograms. But it's actually the mass, which is measured in kilograms. Weight, that's actually measured in newtons. I know, isn't the English language very confusing? The final force, that's lift, which is the upward force that acts on the plane. And this is generated as the air moves over the wings of the plane. So, to move forward, we need thrust. The forward movement causes a drag on the plane. The plane also has a mass and a weight, and to go upwards, the plane, it needs to generate a lift force that is more than that downward weight. These forces, they're all related to each other. If there's no thrust, then there's no lift. If there's no lift, then there's nothing to work against the weight of the plane to raise it in the air. If the lift vanishes, the plane, it can only go one way, downwards. At initial takeoff, there's very little difference between a plane and Iron Man's suit. They're both sat still. To take off, the plane, it would apply forward thrust through the engines. The plane speeds up, starts to generate lift over the wings. The lift eventually becomes enough that it's greater than the downward weight, and the plane, it takes off. With Iron Man, all he's got to do is fire the jets in his suit. These jets, they produce thrust, which gives them speed. But because the jets are arranged so they're pointing down, the thrust from these also generates the lift. So Iron Man flies up into the air. But how much would that suit weigh? Let's work through an example of this. We're going to start with some assumptions. We're going to say Tony Stark, he's got a mass of 70 kilograms. The surface area of his skin is 2 meters squared. That's the area that's got to be covered by the suit. The average thickness of the suit, we're going to say is going to be 5 centimeters. The suit, it's made from a gold titanium alloy, and that was first mentioned in the 2008 film. The density of this alloy, we're going to say is 8,000 kilograms per cubic meter. Now, let's do some maths. I know, that dreaded mathematics. We need to work out the volume of the suit. This is the actual amount of alloy that will be needed to make the suit. To work out the volume, we multiply the surface area by the thickness. So this gives us 2, which is the surface area, times 0.05, which is the thickness. And when we calculate that, it gives us a volume of 0.1 cubic meters. So that's how much alloy is needed. We've now got the volume. We already had the density of that alloy from our assumptions. So let's work out what's the mass of the suit. And that's the density multiplied by the volume. This gives us 8,000, the density, times 0.1, which was the volume we've just worked out, and that equals 800 kilograms. So the mass of the suit is 800 kilograms. Now that's one heavy suit, isn't it? We know from our assumptions that Tony, he's got a mass of 70 kilograms. So the total mass for the suit and for Tony is 870 kilograms. The downward force on the suit, that's the weight. It's the mass within Earth's gravitational field. Earth's gravitational field is approximately 10 meters per second squared. So the weight would be the mass multiplied by that gravitational field. This gives us 870 multiplied by 10 and results in a force of 8,700 newtons. To fly, the suit would need to generate more than 8,700 newtons of force to lift it off the ground. An aeroplane, that can generate many kilonewtons. That's what lets them fly. That's why they've got those massive big engines. There aren't any current engines that can produce 8,700 newtons in a suit. But there are jetpacks available that can be used to achieve this. Current jetpacks, what they do is they use a backpack-style main jet to create the thrust and the lift. To take off, the jets are fired, these create thrust, and the suit rises into the air. To change direction, the suit has got jets in the user's arms. Changing the angle of the jet, that's what causes the suit to change direction. There are a number of current jetpacks. They all work in a very similar way to allow a human to fly. But these jetpacks, they only need to handle the mass of a human. They don't have to lift the Iron Man suit as well. When you add in the extra 800 kilograms of mass, the jetpack is not currently able to provide enough thrust and lift to allow the suit and the man to fly. I've really enjoyed looking into this one. And I know I've used a fairly extreme example. I mean, to be honest, if the Iron Man suit was the mass and the size that we've used, it wouldn't really matter that he couldn't fly. He wouldn't be able to move anyway. Well, he would, but he would need some kind of hydraulic system built into the suit, which would further increase the mass and also the size of the suit. Research is still going on into jetpacks. They're improving all the time. The jetpacks that are around, they do allow some limited flight. Certainly not to the level of Iron Man, but it's a starting point, and the technology, it's continually evolving and improving. And you never know, another 10, 20 years, and we may see Iron Man flying around. Had fun with this one, as you may be able to tell. I love looking at the comics and seeing how there is real science that you can tie into it. What are your thoughts on these types of videos? Please drop a comment down below. What videos would you like to see me doing going forward? Please hit the thumbs up button. Every time you like, every time you comment, just helps with the YouTube algorithm. If you haven't already, please subscribe to my channel so that you can get new videos as I release them. I'll talk to you again soon.